Hi, my name is Kyle Andres, and today I'll be showing the lab assignment number 3. So, the main goal of this lab is to implement a circuit that drives the time multiplex quad 7 segment display and to present it on a real digital blackboard. So, the main design description and requirements for this lab is to use only one clock and no latches. So, the clock as well as the inputs, the four inputs that we can use. And once we have a working design source code, which is based on the base source code given in the lab manual, we can then test the design by using the test bench code given in the lab manual and simulating it. Once we check that the logic is correct from the simulation, then we can start synthesizing the design so that we can check all the errors and warnings. And once that's done, we can implement the design into the Blackboard using the constraints files also given in the lab manual as shown here. And once that's done, we can then turn in the we can turn the zip file in. So I'll be showing the source code right now. So for this one module, this one initializes the inputs and the outputs. That's the clock and the four inputs, which is in this case N0, N1, N2, N3, and the output is N and SSEG. So this assigns the decimal point to off, and this declares the signal to see which bits pretty much is most, which bit we're on. So as we can see, this is the 4-to-1 multiplex mux, and this initializes the input, input, which 2-bit input it is. So for this one, for this case, is 00, which corresponds it to the input 0 and shows all the specific um, cases for it, which is pretty much a 0 to F for input 0 and input 1, as well as input 2 and input 3. And once that cycle's done, this is pretty much a decoder that enables the digits, and we can see that this 2-bit input shows digit 0, and this shows 1, 2, and 3. And once that's done, the just repeats. And yeah, that's it for the source code. And this is the test bench. And this is the simulation to check. And we can see the clock changes to 0 to 1. And um, this is the constraints file for the Blackboard. So I'll be showing the Blackboard results right now. And okay, we can see that it's a 00 and none of the inputs are on. So each four corresponds to pretty much F. I don't know if you can see it that well. If it's too bright or I needed to, but yeah. So we'll be going through the test cases. So 0000 is just 0, outputting 0. It's 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 10, which corresponds to A, if you can see it right there. Then 11, B, 12, 13, 14, which is E, then 15, F. And if I'll be showing the other test cases, only a few of them actually, because actually I'll show every test case. So this is 0, 1F, this is 2, 3F. You see the first this is 4. Give me a second. 3, 4, 5, F, 6, 7. Then we got 8, AF, and 9, AF, which corresponds to that. B, BF, and C. Second. 9, 10, 11, 12. This is 12. Pretty much this is all. I'll be showing 0, F, 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 and you can see all the inputs are on. So this is input 0, input 1, input 3, input 2, and then if I click all the buttons into the leftmost one, we can see that this showcases F, 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 and this is all the inputs shown. Yeah, that will be it for lab 3. Thank you.